Welcome to AI Evaluation. Stay tuned as we explore, analyze, and evaluate the best in AI technology, bringing you the insights you need. Humanoid robots might look amazing in demo videos where they perform tricks like dancing, flipping, or lifting weights as though they're athletes from the future. But when one suddenly starts thrashing around uncontrollably, it's a different story altogether. That's exactly what happened to the Unitree H1 humanoid robot named Dre during a test session, and the entire incident was captured on video. Shared by Robotics' 6 Live on social media, the footage shows the robot suspended in the air by a crane when it suddenly begins flailing wildly. It ends up smashing into equipment, damaging the crane structure, and causing nearby engineers to scramble to safety. The situation is chaotic. In the video, one person can be heard shouting, "What the aya did you guys run?" While another, likely Rex CTO Amanda Watson, yells in shock as the robot swings its limbs around midair. The context behind the incident is crucial. As Six explained, the malfunction happened because a full-body control policy was triggered while the robot's feet weren't on the ground, which caused an immediate loss of balance, resulting in the robot's erratic behavior. In other words, it was as if someone slammed the accelerator on a car while it was up on jacks. The system couldn't respond, and things went haywire. But of course, most people online focused on the dramatic moment of the robot going haywire, rather than the technical explanation. It looked like something straight out of a Terminator movie. What's even more alarming is that Dre isn't some experimental prototype hidden away in a lab. It's based on the commercially available Unitree H1, which anyone can technically purchase. Standing at 5.9 feet tall and weighing 104 pounds, each of its joints can produce up to 365 pound-feet of torque. That's significant muscle power. This robot is designed to run, lift, balance, and even perform stunts like backflips when used by a developer or robotics team. It's capable of impressive feats, but when something goes wrong, like a glitch or misconfiguration, it has the strength to cause significant damage. And in the video, it nearly did just that. This isn't an isolated occurrence. Back in May, another video surfaced showing a similar robot model going berserk in a Chinese testing facility. Suspended by a crane, the robot began flailing uncontrollably, knocking over a nearby computer and forcing 2 workers to run away. The video, which looked like a scene from RoboCop, spread rapidly online. It turned out that the robot had been triggered by a coding error, and one engineer was able to stop it by adjusting the base it was mounted on. But the robot's erratic behavior didn't end there. Earlier, in February, another humanoid robot grabbed attention at a public festival in China. While behind a safety barrier and surrounded by spectators, the robot suddenly lurched forward, startling the crowd. Security swiftly intervened, bringing the situation under control. But the video sparked the same question once again. What happens when these robots act unpredictably in public spaces? At this point, a pattern is emerging. Advanced humanoid robots are making their way out of research labs and into the real world, and we're seeing just how unpredictable they can be, especially in high-pressure testing situations. This brings us to a much larger issue. How do we define safety for machines that walk, act, and move like humans, yet have the power to deliver a punch strong enough to break bones if something goes wrong? The team at Humanoid Hub shared some interesting insights, comparing the situation to the early days of automobiles. A century ago, in the US, there were 20 deaths per 100 million miles driven. Today, that number is below 1.5, a dramatic improvement. While it's not zero, the reduction is significant, and the same principle could apply to humanoid robots. We're currently in the early stages, where robots can be unpredictable, sometimes even chaotic. They'll malfunction, make mistakes, and even be misused. But this shouldn't be a reason to halt progress completely. Over-regulating out of fear could stifle innovations that could save lives, assist the elderly, take on dangerous jobs, and make society more efficient. The reality is that humanoid robots will never be 100% safe. There's no such thing as flawless software or unbreakable hardware. Too many variables come into play: software bugs, hardware wear, freak accidents, or even human error. However, this doesn't mean we should abandon the idea of humanoid robots. The key is figuring out where to draw the line. How safe is safe enough? To get there, the solution might lie in building real-world data, just like we did with cars, planes, and industrial machines. And that's exactly what China appears to be focusing on. On July 18th, they opened a vast new AI robot training ground in the city of Mayan, located in Sichuan province. This is no ordinary lab. It's a comprehensive platform designed to train, test, and refine humanoid robots in high-stress scenarios. Think of it as a boot camp for robots, with research facilities, testing zones, commercialization support, and, importantly, extreme environment simulations. The goal is to address major hurdles in robotics: lack of quality data, insufficient real-world feedback, and the challenge of testing robots in unpredictable settings. Real environments are messy. There's dust, noise, interference, human movement, awkward angles, and tight schedules. A robot that works flawlessly in a quiet lab could behave very differently on a construction site or in a busy subway station. According to officials, the training center will focus on key areas like system integration, core algorithm development, and pilot manufacturing. There will also be 2 large-scale scenario training bases where robots will be tested across different sectors, such as emergency response, manufacturing, healthcare, urban services, and tourism. These tests will go beyond typical lab conditions, stressing the robots in ways that replicate real-world challenges. China's ambition here is vast. By the end of this year, they hope to have at least 7 robotics companies working inside the training ground. By 2027, that number will rise to 30, with plans to launch over 10 new robot products and incorporate more than 30 advanced technologies across multiple sectors. This initiative is backed by a special fund from the provincial government, with a clear aim to make the training ground a national leader in embodied AI development. The commercial side of this is also significant. China's humanoid robotics market is projected to be worth 870 billion yuan, around $121 billion, by 2030. While the robot failures may seem alarming now, they're part of a much larger picture. It's not just about fixing bugs, it's about scaling up an entire industry. These robots aren't just designed for research or entertainment anymore. They're being developed to handle real-world tasks. Whether that's lifting boxes in warehouses, performing delicate medical tasks, responding to emergencies, or even engaging in robot versus robot combat, like what the Rocket team seems to be promoting. This creates new possibilities, new risks, and an urgent need for updated safety frameworks that go beyond just programming. If humanoid robots are going to be integrated into our daily lives, whether walking next to us on sidewalks or working alongside us in factories, we need to ensure that we're prepared for when things don't go according to plan. This means developing better training systems, smarter fail-safes, clearer regulations, and increased transparency about what these machines are doing. So yes, a robot flailing around on a crane during a test is frightening, but it's also a reminder that we're entering a new era. One where these machines are no longer a product of science fiction. They're real, they're powerful, and they're learning fast. Thanks for watching. Share your thoughts in the comments.